What's going on, folks? How's it going with you? Can you hear my voice? Okay, so here's what I'm discovering. A lot of you guys are coming back and saying, "Hey, your Rat 3 homework sucks." Um, right? Like that's what you guys are basically saying. Your Rat 3 homework is a little backwards. It doesn't make any sense to me and whatnot. And I can't disagree with you. I think because it does kind of suck. I didn't know how to necessarily tell the computer to do this. So really, what I should do, I think what I need to do is I need to change the Rat 3 homework so that it doesn't give you these options, but rather it says, what is the horizontal asymptote of this? What is the horizontal asymptote of this graph? Like, I in this case, you can look at this and say it's straight up zero. Does that make sense? Because the degree of the denominator is bigger than the degree of the numerator. Y equals zero, that's the horizontal asymptote. I think that's how I should ask the question. I should just say, what is the horizontal asymptote? Y equals, and you guys should put zero. I shouldn't do this game where you have to figure out which side it comes in from and all of that kind of stuff. Because it could be this one, this one, this one, or this one. Those all have a horizontal asymptote of y equals zero. The first four options, it could be that. Does that make sense? And the reason why I did it this way, is because when you look at this and you use that horizontal asymptote trick that I showed you, where you just look at the degrees of these polynomials, you're able to immediately tell right off the bat, hey, what the horizontal asymptote is. But what you don't necessarily know how to do is choose which one of these four it is, because all of these have horizontal asymptotes of zero. Now, I'm not going to get rid of it completely because I'm realizing that in Chapter 4 and in Chapter 5, you now have the tools to be able to choose between these four. So you should be able to do this in Chapter 4 and 5. But when I'm asking from you guys in Chapter 3, you don't yet have the tools to be able to do this. You need to not only worry about the horizontal, in order to figure out exactly what this picture looks like, you not only have to worry about the degrees of the polynomials, that horizontal asymptote trick we have, but you also have to additionally worry about the vertical asymptotes, how many there are, and all of that kind of stuff. And then whether it's positive, negative coefficient, that kind of stuff. The y-intercepts, exactly. When you put all of this information together, you'll be able to get this kind of information. So here's what I'm going to do. In Chapter 3, I'm going to, when I ask, if I teach this class next year, I'm going to ask the students, instead of asking them a question like this, I'm going to ask them straight up, what is the horizontal asymptote? In this case, it's zero. In this case, over here, it's negative 2. In this case over here, it's 1. So, and I don't know why I asked it like this. I think it's because I forgot exactly. I didn't necessarily. I wasn't thinking about what you learned up to that point. I was thinking about like making all of this together. I apologize. So here's what I'm going to do. All right. Here's what I'm going to do. For rat 3, for those assignments that I ask you the question in that fashion, I'm going to go through and give everyone who took that test automatic 12 points. Even if you got all of them wrong, if you at least took it, I'm going to give you automatic 12 points. If you didn't even take it, I'm not going to give you automatic 12 points. That's not fair. But if you even tried it, if you attempted it, hey, guess what? Automatic 12 points. Does that sound fair to you? And I did that already for this 14-point assignment that was due, I think, the other day. Like, I think it was not page 15, but page 14 or something like that. A second. Sorry, my computer's slow a little bit today. There. Okay, here we go. So for Rat 3, it was page 8 and page 15. I gave you guys those points for free. All right? Because I know you know how to do them. I'm just asking you guys the question. So what I'm saying is this. See this homework from Rat 3? In order to answer the question in the way that I asked it, you would have had to have understand information from Rat 4 and Rat 5. So I ask you very similar types of question in Rat 4 and Rat 5, but those are fair game. Can you guys see my screen? Oh man. All right, I'm sorry. Other people can, even Jenna, who's off island as well. You might have to log out and log back in. I'm sorry. All right. So when I ask those types of questions in Rat 4 and Rat 5, those are totally fair game to ask because that requires all of the pieces of the puzzle put together. And when I ask you these questions in Rat 3, I should have just asked you, what is the horizontal asymptote? Is it 0, 2, 1, 3, all of that kind of stuff. Sound good? All right. And what I'm going to do is I'm going to freebie all of these points. Did I make this due? Oh, I must have forgotten to put it as a due date. Yeah, I'll freebie all of these points for you. There we go. Merry Christmas. All of that kind of stuff. And I apologize for any inconvenience it may have caused, but you understand how easy it is, right? It's not actually hard to find the horizontal asymptotes. You just look at the degree of the polynomials, top and bottom, and then if one is bigger, then that one dominates. If the one on the denominator is bigger, then the horizontal asymptote is 0. If the horizontal asymptotes have the same degree, then you just look at the numbers, the coefficients, and that tells you what their answer is. It's really that easy. What I wanted to do today is actually that was actually the assignment that said I need to fix it. Oh, okay. In this assignment, it says I need to fix it. I decided not to even assign it. I probably should just unpublish it. Yeah. Oh, it's probably a really good assignment that I liked, but I just need to figure out how to ask the questions correctly and all of that kind of stuff. All right. Sophia, I think what you're asking is what happens if I just straight up have an x in the denominator? Well, that has an x in the... All right, what if you have an HA that has an x in the numerator? Oh, okay. Okay, I think, Sophia, what you're asking is like... Okay, I'll tell you what. Let me close this website. Desmos. I think what you're asking is something like, what happens if I have 3x cubed divided by x squared minus 5? Or something like that. How's that? Yeah? Okay, cool. All right. Then what happens is your graph, okay, so the way you can approximate this is actually 3x cubed divided by x squared, right? And we know to simplify that to basically be 3x. Because there's 2 x's on the bottom, and yeah, 3x over 1, exactly. So I'm just going to write 3x. We cool? Now, you guys are saying, wait a second. That blue line looks nothing like this red line. And you're telling me that at the ends of this graph, these things should look the same? And I'll say, okay, fine, let me zoom out. You see, what happens is there are actually two vertical asymptotes, as you can see in the quadratic that's in the denominator of this original function. And so the one that we saw at the beginning was only the middle part, and then we still have these two horizontal asymptotes, and they come up like this. And I would definitely agree that the horizontal asymptote, there is no horizontal asymptote. What actually happens is it's what we call a slanted asymptote. Does that make sense? Where this horizontal asymptote, quote unquote, this blue line, looks kind of like a 3x, just a straight 3x. And that's how the thing goes to when it gets to the end. All right, I thought you got it wrong because I checked Desmos, but I didn't zoom out enough. Yeah. So you see, the math actually doesn't lie. Desmos didn't lie to us. We just only looked at part of the picture. When you zoom out, you realize, hey, there's some funky things going on outside here that you didn't see. And I thought that was interesting too. Because when I first looked at this, I was like, wait a second, what's going on? There is no way that this blue graph will ever look like that red graph. Or the red graph will ever look like the blue graph. It turns out we didn't see the whole picture. Like literally see the whole picture. Does that make sense? Which is perfect because that's exactly what I want to start talking about today. So we're going to basically continue what we started on Monday, which I thought was a good lecture. I thought that was a good class. We're going to continue what we started on Monday. Let me just find... Wait, no. Here? No, here. Okay, wait. Give me a second. Oh, that's what I want. There. This one. And I think on Monday, all I did was I looked at a bunch of graphs, and then I said, let's try to make those graphs. All right, let's try this one. Let's see. All right, this one looks good. This one looks tough. Okay? All right. So, and we actually found that Chapter 5 wasn't that hard. Chapter 5 was just playing with this stuff. So, first of all, let me kind of recap what we did on Monday. Looking at the graph, we want to be able to figure out what the equation is based off of the graph. In Chapter 4, I gave you equations, and I told you find the y-intercepts, find the x-intercepts, find the horizontal asymptote and the vertical asymptotes, and that will tell you what the graph looks like. In this case, in Chapter 5, I'm doing the backwards. I'm giving you the graph, and then I'm saying, from the graph, you can pick out the horizontal asymptote, the vertical asymptotes, the x and y intercepts. Tell me what the equation is. Does that make sense? Now, the first thing I like starting with is when doing this game, and Bradley and Lucas, I remember you guys being here the last time, so you guys can definitely help us out with this game, is the first thing I like doing when I'm translating from a graph to an equation is finding the vertical asymptotes. Where are the vertical asymptote, and what does that mean for my denominator? All right, your vertical asymptote looks like it's at 2 and 3. There's one more. So -2 and 3, and also where? And 1. So that means my x plus 2, see that right there, this part of the equation right here accounts for that vertical asymptote. And then according to Sophia, which I totally agree with her, there's the x minus 1 and the x minus 3. Are we cool with that? And I didn't actually put this thing in there yet. I just put a 1 up there just so that it doesn't give me like a blank graph. So now this is an actual equation. But you can see even in this graph, there's the there's the vertical asymptotes are exactly where we want them to be, at -2, +1, and 3. Now, the next thing I look at is, after I look at the vertical asymptotes, I look at the x-intercepts to get the numerator exactly. Sophia, you said you weren't here? Because you're getting this really quickly right off the bat. Anyway, let's do the x-intercepts. Where are the x-intercepts? Where are the x-intercepts? Okay, Sophia's saying that your equation is going to be x plus 3, x minus 2, x minus 4. I agree. X plus 3, x minus 2, x minus 4. Cool. Cool. That's it. Now Bradley's saying no. Not done. Lucas is saying no. Okay. What's the problem here? I agree. I completely agree. We are almost there, but we're not quite there. And the reason being is because this y-intercept is wrong. You guys are all picking up on this. The y-intercept of the graph is 8. The y-intercept of my equation is 4. So Bradley is suggesting, or Sophia is suggesting, there should be a 2 out in front. And this 2 acts just like the A of the parabolas that we did with the gummy bear thing, right? If A is a big number, then it stretches the gummy bear. If A is a small number, then it compresses the gummy bear. If A is negative, it flips it upside down. And Lucas is asking why the number 2. Sophia, why don't you explain it? Okay, Bradley's explaining it. No, that was Sophia. Never mind. Yeah, exactly. Because right now, currently, the y-intercept is 4, and it needs to be 8. So in order to basically stretch this thing vertically by a factor of, if we stretch this thing vertically by a factor of 2, that won't change the vertical asymptotes. It will still have the same vertical asymptotes. It will still even have the same x-intercepts, but it makes my graph go to make sure it crosses at that point. Why would it be 8? Wouldn't 2 times 3 times... Okay, all right, here. Remember, Lucas, in order to find the y-intercept, you plug in x equals 0, okay? Right? So if you wrote this thing down and wanted to know what 8 times -2 times -4 divided by +2 divided by -1 divided by -3 is, it's 4. That's your current y-intercept. Your new y-intercept you want to be 8. So you put a 2 out in front of here, and then you plug in x equals 0 again, and then 2 times 3 times -2 times -4 divided by 2 divided by -3 divided by -1 gives you 8. Does that make sense? Now I'm cheating because what I'm doing here is I'm graphing all of this and seeing the graph right off the bat. To me, that's kind of cheating because, I can play with this and see how this thing gets affected. But it's good practice for us. I'll tell you what, I'm going to switch these windows and see if I can play this game a little better. Why would you get the same y-intercept if the 2 was in the denominator? My answer is you wouldn't get the same y-intercept. If the 2 were in the denominator, it would be like having a 1/2 as your A. And we know that when you have a fraction as your A, it vertically compresses the A. So it would actually go from a 4 to a 2. You would have the same x-intercepts though, -3, +2, and +4. And you would have the same vertical asymptotes, but your y-intercept would change. We're vertically stretching this thing. So let's see if I can do this without seeing the graph. Okay. All right. I got an idea. Okay. This one's pretty big. Actually, this one's good. This one's good. Let's do this. Nah, you guys can figure that one out on your own, I think. I like this one. This one's good. Okay, cool. Let's do this one. All right. So check this out. Here's my graph. I have vertical asymptotes. Okay, so I know I have a fraction. I know that in the denominator of that fraction, actually here I'll do this. X. Okay, I'm just going to turn this off. All right. I know that in the denominator of my fraction, I'm going to have a x plus 3 and an x minus 3. Perfect. I agree completely with you guys. All right. Let's talk about this one now. In the numerator, what am I going to have? I'm going to have an x minus 4 and x plus 4. Yes. Okay. Wait a second. You're saying you want me to put a square over here? Now, why is that? Why would you suggest something crazy like that, my friend? Because of bouncing. Because what happens over here is the graph comes down at positive 4, and the x-intercept that tells me its x is positive 4 is this one particularly right here. Hits that point right there, and it doesn't go through, it bounces off. Okay. Okay. All right, you want to try graphing this, or you want to take a look at your x-intercept, your y-intercept? Let's try graphing this real quick. Okay? Did we get it right? No. No, we didn't get it right. Put a negative in front? All right, fine, I'll put a negative. That just takes the thing and flips it upside down. Okay, we've got that bouncing property that you guys wanted, right? We also have it going through right here. It's not the right direction. Okay, it's actually, it could be the right direction. Here's what I want you guys to look at. You know how you guys notice that this thing comes and bounces off for the x-intercept? And you guys were smart enough to say, hey, that thing's squared. Well, normally for vertical asymptotes, what happens is your graph goes down to negative infinity, and then like asteroids, it pops up at the top of the screen from positive infinity as it crosses the vertical asymptote. Both of your vertical asymptotes don't do that. One of them is a little bit different vertical asymptote. This vertical asymptote goes up into infinity and comes down back from infinity. So that's one. Let's try squaring it and see what happens. Which one do I square? This one right here, the x plus 3, or the x minus 3? The minus 3, exactly. There we go. Oh, let me take off that negative sign that was suggested of me. Cool. Sophia's asking, why did you square the x minus 3 as opposed to the x plus 3? Okay. Jenna, do you understand why we squared the x minus 4 and not the x plus 4? Not Jenna, but Sophia? Or I don't know who I said. Yeah. Okay, you did. All right, good. Because that x minus 4 associates with the x, the x-intercept being positive 4. Well, this vertical asymptote at positive 3 associated with this denominator part being the x minus 3. That's why we're squaring that one and not the other one. Does that make sense? And you know, wait, Bradley says no. Bradley, are you confused as to why I put the square on this one and not the square on this one? Okay. Also, I want you to notice something. What do you mean relate to? I don't understand. Oh! I mean, you mean what do I mean by associated with? Oh, okay. All right. All right. If I told you one vertical asymptote is at negative 3, you would have written this thing down right here. If I told you the other vertical asymptote is at positive 3, you would have written this thing down right here. It's at that positive 3 vertical asymptote that we get this square property happening, where the asymptote goes up into the air and it comes down from the air. So that's why I'm squaring that one, because the graph told me to do it. Does that make sense? And notice, one of the things I noticed before I even graphed it is, before I even graphed it, when I told you, hey, let's look at the graph and see if it works, I knew that this wouldn't work. Why is that? Well, because in my mind, I thought to myself, you know that horizontal asymptote that we talk about? The degree of the polynomial upstairs is a cube, actually, and the degree of the polynomial downstairs is a square. So I can actually, model that as x cubed over x squared, right? And if you look at this graph, yeah, I agree. That asymptote, this green asymptote, looks a lot like where this red one's going to. Anyway, the reason why I can take a look at this graph and tell you, hey, you guys got the wrong one right off the bat, is because this would produce a slanted asymptote. It would not produce a horizontal asymptote. The only way for this thing to produce a horizontal asymptote is if the degree of the top was the same as the degree of the bottom. Basically, there's the same number of x's on top as there are on the bottom. So I knew there had to be a square on one of those. Either there was going to be another parentheses downstairs, or with a different number like x plus 5 or something like that. Either there was going to be and this would give you a horizontal asymptote that is like this right here, or you're going to have a square. Does that make sense? All right, cool. So this is, in this case right here, this is a slanted asymptote. Let's try this one. Yeah, we have time. Good. We'll do this. All right. So from scratch. I know this is a fraction. I know that, let's start off with the denominator. What's the denominator going to be? X minus 1. Good, I agree. Is it to the first power or the second power? It's to the first power. Good. Yes, exactly. Because look, how the vertical asymptote looks, it's coming up to the infinity and it's appearing back down to infinity. It does the opposite thing. The asteroid thing is happening, yeah. And I can't necessarily say, to be honest with you, I can't necessarily say that it's the first power or second power. Really, what I can only say is it's either an even power or an odd power. Because technically, maybe this vertical asymptote could be cubed, and it would display that same kind of property, just a little bit more extreme. Am I making sense here? But for the most part, I'm going to stick with it being to the first power. That's what I think it is. You can figure out the individual powers by looking really here. You have to look at the whole puzzle altogether. Anyway, let's go on to the x-intercept. So what is the numerator going to look like? All right, x plus 1, x minus 2. Exactly. X plus 1, x minus 2. I love this chapter because it's all of this stuff comes together. It's almost like it's like where you take all these tools and we can actually finally build something out of it. For the most part, all you've been learning is tools, tools, tools. But now I'm actually applying stuff that we know. And what's really cool is, you know how I made such a big deal out of gummy bears in when I first met you? It all comes back to that as well. Like that comes into play. All right, yes, now you're at Bob the Builder. I love Bob the Builder. Can we fix it? Bob the Builder, yes, we can. Scoop, Muck, and Dizzy. The Ian words. All right, anyway. Yeah, the one that trips me out is the scarecrow, right? Like the potato man. It's like everything else is pretty cool, even the talking trucks. But the potato man, what the heck is that? Anyway, moving on. Is this the right graph? If I press that button, will that graph be the exact same? Let's look at the horizontal asymptote just to try. All right. The horizontal asymptote tells me x squared on top, x on the bottom. That means it's a slanted asymptote because x squared divided by x is just x. No, Sophia's saying, I think that could be the correct asymptote. I think we're in good shape here. Okay. What about this? Is our y-intercept good? Just by looking at this, is our y-intercept good? Yes, because if I plugged in 0 into here, here, and here, I would have 1 times negative 2, which is negative 2 on top, and I'd have negative 1 on the bottom. That gives me positive 2, which is according to that. So I'm going to venture to say that that is my graph. And I think that I would venture to say, yes, you're absolutely correct. I'm curious to know if I make this a cube, though. What would happen? Ah, I see. Okay. If I make this a cube, here's what happens. All right, take a look at this. Now, different things happen. At that particular asymptote, that same property occurs. You've got your asteroid thing happening here. But all of a sudden, when you made this thing cubed in the denominator, the degree of the denominator became bigger than the degree of the numerator, and your horizontal asymptote is actually 0. Give me a second. I got a phone call. Hello? Yeah. Oh, cool. Yeah. Okay, so what I need to do is when you announce that thing and that all stuff comes out, I need to make sure I ask you for the H version and everyone else gets the 1. Okay. So I can make these changes during open enrollment or if my wife gets insurance or loses insurance. Awesome. Thank you so much. Okay, bye. All right. Sorry. Insurance stuff. Really important. Make sure you guys take care of insurance stuff when you guys get old. I want to take a look at one more thing real quick. Let's do this one. Because this one it looks a little different from anything we've tried before. I'll tell you what is it that's different about this one that that is different from all the rest? I'll tell you what. There's a parabola. Okay, I love what you're thinking here is, and I'm going to go through this because I actually have to get my other class started soon. So I'll start telling you the answer for this one. I'm not going to inquiry based most of this stuff. All right, what's happening here is it looks to me like your horizontal asymptote is not 0. It's not a horizontal line someplace off. It's not even slanted. It almost looks to me like your horizontal asymptote is like that. Would you agree, or would you agree with me? So I'll tell you what. Whatever our answer is, I know that the degree of the numerator is probably going to be twice the size of the denominator. Anyway, let's go through this problem. I'm going to start off with my vertical asymptote. That's at x minus 1. I think that you all can agree with that. Got it? It's a x minus 1 to the first power because you've got this opposite day thing going on. The next thing I'm going to do is I'm going to do my numerators, and I would say x plus 2 and x minus 2. Are we cool with that? Now, when I'm looking at this right here, exactly, very good, Sophia, but before I get to that, when I'm looking at this right here, it looks to me like the degree of my numerator is 2, and the degree of my denominator is 1, and I wanted the degree of my numerator to be two factors bigger. So, 2 minus 1 is just 1. It needs to be, the degree of the numerator should be cubed, not just squared. Which, also Sophia pointed out that, hey, that particular intercept that you have, that should be squared because that would give you that bouncing property. And if you look at this, the degree of the numerator is a cubic function and the degree of the denominator is x to the first power. Modeling that would be x cubed over x, which simplifies down to x squared. I think we're in pretty good shape here. The last part I would do is I would just check my y-intercept real quick. If I plug in 0 for everything, what is my y-intercept? 0 for x. What is my y-intercept? It's -8. Okay, good. All right. So let's press the graph button and see if we got anything close. Oh, snap. We're so good. Yay! So, when you do your homework, I want you to play with Desmos. I want you to play with this thing. Learning this thing is really just a lot about playing with these things. And I don't even know if I'll be honest with you, I don't even know if when I first learned this, if this is how I was taught it. I'll be honest with you, I was a terrible math student in high school. But but the thing is, I did so many darn problems. Like I never listened to the teacher, but I always did my homework. It's a little backwards. I know. It's a little crazy like that. Anyway, I never listened to the teacher. I always did my homework. And so when I would sit down and do my homework, I would have to struggle a lot because I wouldn't listen to the teacher how he did it. And so I would make up my own way. Um, I would make up my own way on how to do it. And what I'm teaching you now, I don't know if it's the way I was taught because I never listened to my teacher. It's the way I figured things out. And the reason why I figured those things out is because you just play with it. You just do a whole, bunch of these problems. You play with it until you get it correct. Yes, I encourage you to do it that way. I'm showing you all of my tips and tricks after years of experimenting with this stuff. I think it makes sense. I encourage you to do something like that. All right, anyway, I'll talk to you later. I love this class. This was a lot of fun. Bye.